Hi, today I'm gonna showcase my my homework, bonus homework project, which is basically the uh, Chinese Red Envelop game that is played on WeChat. Basically, what the game consists of is it can be played among friends, in which one can send money to everyone, and the person who receives it the first gets to hold on the money, and everyone else cannot receive the money. Uh, this is a classical example of Lamport logical clocks. Basically, Lamport logical clocks tries to synchronize time between decentralized systems where there is no connection with the central server, and it tries to globally order the events because handling a global clock is very hard. So I'm gonna do it on a Linux machine, and I've already created three virtual machines which are trying to interact with each other. I have three tabs open as you can see below, each one for different machine. I can show Ubuntu 01, Ubuntu 03, and Ubuntu 02. Um, and all of them have the same copy of the program Red Envelope Elgo. So, okay, I'm sorry. Okay, so I tried to deal with it using a server and a client earlier, but what happened was when I create two different files, I'm not able to synchronize the sending time between both of those. So then I realized that every person is trying to send and receive the message to the same phone, so the timestamp is automatically synchronized using that phone. So basically, I created the server and the client, basically the sending message and the receiving message both on the same file, that is the red envelope. What I'm going to do is I'm going to run the program on each one of the machines for some time and let it run. Okay, so I'm going to let this run for about a couple of seconds, or maybe like 10 to 15 seconds, just so that I at least have one example to show where somebody receives the money, and I can show a series of trails where somebody is sending or acknowledging or request release. So I can, while this is running, I can give a basic tutorial of how I have done it. So in the Lamport logical synchronization clock paper, uh, on there are 5 rules given as to what needs to be done basically to implement logical clocks. I have basically just followed those steps, and in the fifth step we will see that it has two implementation rules. One says that every the message anyone can receive the money only when the message is in the top of the queue, and the second rule is that unless you have acknowledgement from everybody in the network, basically the other two machines here, saying that you can claim the money, you don't claim it. So I'm gonna stop running it now. Okay, wait, I think this ran and this ran. Okay, so if you see, it is creating a log file ubuntu 01.out. If you see, this is creating ubuntu 03.out, and this is creating, basically what these are doing is it has the I'm basically taking the machine host name and appending it with the out file. That seemed logical. I'm gonna go through each one of these log files. I don't know why the machine is running really so. Oh, sorry. Okay. So this is the first file. So now I'm gonna explain the different kind of messages that are going through. So you can see send, because I ran this on this machine the first, obviously it is trying to send, it is basically some random integer trying to send messages, and you can see that it is sending with different hashes. Hashes are basically so that we have unique IDs for each message, and then the sender is Ubuntu one. Sender is always the machine that is basically we are on, because I can only be the sender, and and then there are different amounts. These are basically random integers because different friends can send different monies. And if you can see the timestamp over here, if you are sending it uh, together, if you're sending a couple of messages together, the timestamp increases by one. So this was, I think, given in the paper where if you send messages, you increase the timestamp by one, but if you receive messages, you take the uh, latest of your clock and the timestamp of the message sent to you, and basically take the maximum of both of them and add one to it. So if you see that it has a send ACK message, which is basically 8, so it must have received something with 7, or basically its own time would be 7, and it would have received it something 5. It would have taken the maximum, added 1 to it. And now we can go to similar are the messages there. So I'm going to explain. So this is the sending red envelope message, then there is ACK message, acknowledgement message, which is basically sent um, when you receive money from basically when you get a message from somewhere, and you have to send a time-stamped acknowledgement message in response that yes, I've received the message. Then the other kind of message is that wants to open, basically somebody who's trying to open but does not have acknowledgement from all the machines, or is not on the top of the queue, it is just trying to access, so it will say Ubuntu 01 wants to open. And then there is this release resource message which a machine will send to both the other machines, saying that release this resource, I was the one who got it first. And so what I'm going to do is I'm going to take example of one of the messages that was already received. I'm hoping something was received. Yes. So if you see the debug message, received envelope money, request ID is this. So I'm going to use this to elaborate uh, basically what are the series of events. So I search this and I see, okay, so the first message that this machine is sending is basically sending an acknowledgement message to the other machine, because I think the other machine would have received this message. The sender is this current machine. So basically the other machine would have received this message first, and then it would have tried to claim it. We'll see the series of event in that Ubuntu 3, but this is the ACK message that this machine sends to the other machine. So now I'm gonna paste the same ID and I'm gonna see. So you will see that Ubuntu 03 wants to open the message this, and sender somebody with, okay, so wants to open, and then we're gonna do an N and see that it has received acknowledgements from Ubuntu 01, and then we do an N, and it has received acknowledgement from Ubuntu 02 also. So basically it has received acknowledgement from both the other machines. So this machine should be the one that should access the money. And when we do another N, we see that this machine now that has released has gotten the acknowledgement message from both the other machines. It sends a release resource message to both the other machines. Basically it broadcasts and says that release this resource, I've gotten acknowledgement from both of you, and I will try to receive this money. I will do N, and we'll see that the next message is received envelope money with request ID this, and the amount is 68. Now we're going to go to the third machine and see and what are the events that have happened in this machine. And we see that this machine sent the red envelope. So this must be the friend who's giving the money away. And then after that, it basically after receiving the message or request resource message, it sends an acknowledgement message that yes, I have received it, and then it already has the name of claimer. So yes, and then it sends the message that received envelope this, and amount is this, and the receiver is the Ubuntu 03. So this machine is basically Ubuntu 02, and it knows that the receiver is Ubuntu 03. Once it receives the money, what happens is hmm, once somebody receives the money, it is added to a set where there is a list maintained for all the received money. That is just to do a simple check, so that we don't keep rotating the same message across the series of messages that are there, just to prevent the traffic on the three machines that we have. So now I'll go to the zero machine again, and I'm gonna see a couple of more messages just to show that this is working correctly. I'll show the received money envelope, which is starting from 0 D0. Okay, I'm gonna copy this and then I'm gonna show the series of this message. Okay, so it says Ubuntu 01 wants to open the message. The sender was somebody else. Amount is this, and then it is receiving the request acknowledgement from both the other machines. That means it should be able to open it, and then so basically you can see all the five messages together. um, it gets a message that it says that Ubuntu 01 wants to open, then it receives the acknowledgement message from both of them, and then it sends a release resource message, and then it receives the money. So if we search it on the other machines, we'll see that this machine is sending the acknowledgement, and then it shows the received money this, and then if I go to something else and do this also shows an acknowledgement and a received message. So I think this is the way Lamport log should work. I'm gonna do one more example. Actually, I think I've shown enough examples. I wanna uh, exit this, maybe go through the code once. I'm gonna show only the basic places where I kind of struggled, because most of the code that I have written is following the steps, the 5 steps in the Lamport paper that are given. So it says that once you receive the message, send a timestamp acknowledgement and so. And the fifth step is basically the one that explains that you can only access the money or access the resource if you have the acknowledgement from all machines, and you have the timestamp that is lowest for that particular message. So I'm gonna go to the code once, and I'm gonna show you that number of pairs are hard coded because I know that there are two machines. Uh, then I've used two sockets. Basically, I was trying to use the single socket to receive and respond, but somehow uh, what happened was basically it was getting a little trafficy, or I don't know what, but some messages I was not able to receive or get. So I basically used two sockets, one to just create the money and send it, broadcast it, and the second sock is doing everything else. Yeah, so basically this is doing everything else. So there are two sockets. Then I've used a manager which basically syncs the different threads that I'm using inside this program. One thread is basically to create the money, and the other thread basically reciprocates to all the other functions. So I'm basically, the threads are my server and clients, which I was not able to do on the two different machines. And and I don't think that there is anything that I need to explain. Everything is explained because it's pretty much straightforward. Uh, yeah, I think this is pretty much it. Thank you.